All right, as promised in the polynomial long division video, I've included a bonus matrix video at the end of the algebra video series. Now, in the polynomial long division video, we were trying to do partial fraction decomposition. So we had an expression that looked like 3x plus 1 divided by x plus 1 times x squared plus 2, and we were trying to break it up into a set of fractions that looked like a divided by x plus 1 plus bx plus d divided by x squared plus 2. Now, in the process of solving this equation, what we had to do was multiply both sides by this bottom factor, which was x plus 1 x squared plus 2. We went through the algebra and we ended up getting an expression that looked like 3x plus 1 equals ax squared plus bx squared plus bx plus dx plus 2a plus d. And then we were able to take this and break it apart into a system of linear equations. So we have equations 1, 2, and 3. So for the x squared terms, we had ax squared plus bx squared equals 0, or in other words, a plus b equals 0. For the x to the power 1 term, we had 3x equals bx plus dx, or in other words, b plus d equals 3. And then for the last and final expression of x to the 0, or the non-x term, we had 1 is equal to 2a plus d. So in other words, 2a plus d equals 1. So all of this right here is a system of 3 linear equations. Linear because there's no squares or divisions or trig or exponents or polynomials of anything weirdness. It's just everything to the power 1. We have 3 unknowns, a, b, and d, and we have 3 equations. Now, as long as the number of equations is equal to or greater to the number of variables, we know it's solvable. Polynomial division video, we solved this system through substitutions. So we solved for one of the equations for one of the variables, plugged into the other, and as we saw, it could get a little messy, and I promised you guys another way to solve a system of linear equations such as this. So the way to do it is to construct what is known as a matrix. So we end up rewriting this expression, this system of 3 equations, into a little, what we call a matrix, which is basically a set of rows and columns of numbers. So what we're going to do is we're going to have a row of our a terms, a row of the b's, a row for d, and then a final row for the answer. All right. So for the first equation, we have 1a, 1b, no d's, notice it's just a plus b, and the answer was 0. For equation number 2, b plus d equals 3, we have no a's, so that's a 0. And what we have is 1b, 1d, and the answer was 3. And then finally, for the third equation, we have 2 a's, we had no b, because there's no b in this equation, we had 1d, and the answer was 1. So what I'm going to do is I'm going to throw up a straight line to differentiate between the actual coefficients of a, b, and d, and the row of answers of what these expressions were, or sorry, what these equations were. So we're going to throw big square things around the whole number, and this right here is what we call the matrix. It's a system of linear equations expressed with a row, each row being an equation, and then each column being all of the a's, all of the b's, all of the d's, and then finally the answers. Now, in that same long division video, I had shown how we could actually solve a system of linear equations by adding one equation to another. So that's actually what the matrix lets us do in a very easy way. So the things that we're allowed to do is one, we can multiply rows. So in other words, if I took equation number 1 and I multiplied both sides by the number 2, the equation would still be true. So I could take an entire row and multiply it by a number. So I can multiply rows by numbers. Now, the same way that I could take an equation and add it to another equation, we can do the same thing with rows. So we can add rows together. And these are going to be the things that we do to help us solve this equation. So basically, what we want to do is we want to multiply rows by certain numbers and then add them to other rows so that this matrix right here will look like 1, 0, 0, 0, 1, 0, 0, 0, 1. And then finally, the answers on the other side. Because if we can make the left expression or the left matrix look like the right matrix, what would that look like? Well, remember that each row is a coefficient. So we've got A, B, C, D. So if we read off the first row, it's going to be 1, 0, 0 plus some number. So we know that A is equal to whatever number's on the top here. Second row, 0A, 0C, so it's just B equal to whatever number's in here. And then finally, 0A, 0B, C is just some number. So if we can make the left matrix look like the right matrix, we can really quickly go, A is equal to this, B is equal to that, C is equal to this. Oh, sorry, I just realized. This one is D. So I've got row A, row B, row D. And then we're going to have some sort of answer where this is just some number X, some number Y, some number Z. So this will be an easy way for us to figure out the values of A, B, and D just by doing a little bit of multiplication and addition. So we can kind of skip the whole substitution thing if you guys didn't like it, because I know that substitution's not for everyone. So how does this actually look like in practice? Well, let's rewrite our matrix really quickly. Remember to always put a line to separate the answers from the actual variables. And so what do I want to do? Well, when we're doing this kind of matrix solving of linear equations, what we try to do is we try and start with a 1 up front and make zeros down below. So the first row already has a 1 in the front. Perfect. The bottom row already has a 0, so that's good. But we see that row number 3 has a 2 in front. So I want to make this 1 get rid of this 2. So what I'm going to do is I'm going to multiply row number 1 by minus 2 so that when I add the rows together, they cancel out. So I'm going to have minus 2 times row 1 plus row 3 becomes my new row 3. So what's that going to look like? Well, first row doesn't change. Second row we did nothing to, so that doesn't change. And then finally the last row. The last row is the one that we are changing. So we're going to do minus 2 times row 1. So we're going to do minus 2 times 1. So it's going to be minus 2 plus 2 equals 0. So notice we've got that 1, 0, 0 the way we wanted. Next, we're going to take row 1, multiply by minus 2. So we're going to do minus 2 times this one, which is minus 2, plus row 3. Well, minus 2 plus 0 is minus 2. And then finally, 0 is perfect, because no matter what we multiply 0 by, it stays 0, and no matter what we add 0 to, it stays the same. So that one's just going to be 0 plus 1. And then same thing here, minus 2 times 0 is 0, 0 plus 1 is still just 1. Perfect. So notice this first column already looks like the way we want it to. Now for row number 2. We want that first digit to be a 1, which it already is, but now we need to get rid of it. we need to get rid of the stuff above and below. So what I'm going to do is I'm going to multiply row number 2 by -1, so I can get rid of the 1 on top of it. So it's going to be minus row 2 plus row 1 becomes my new row 1. And then I'm going to make zeros underneath. So I've got a 1, I want to get rid of a -2. So what I'm going to do is I'm going to multiply row number 2 by 2. So 2 times row 2 plus row 3 becomes my new row 3. So we're going to start with this top expression. -2 times 0 is just 0, plus 1, it stays 1. -1, so -1 times 1 is -1, plus 1 is 0. -1 times 1 plus 0. So -1 plus 0, this one becomes -1. And then -3, because remember, row number 2 is being multiplied by -1. So -1 times 3 is -3 plus 0 becomes -3. Now row 2, we didn't change. So that's just going to be 0, 1, 1, 3. Now for row number 2, you might have seen the pattern that whenever we've got a 0, it doesn't affect anything else. So this 0 is not going to do anything to the 0 below it. 2 times row 2 plus row 3. So we're going to have 2 times 1, which is 2, plus -2 gives me a 0. 2 times 1 is 2, plus 1 gives me a 3. Perfect. And then finally, we're going to have 2 times row 2, which is 3 times 2 is 6, plus 1 gives me 7. We throw the line to differentiate between the variables. And boom, just like that, we're almost done. Because if you notice, we've got the first column looks like 1, 0, 0, the way we want. Column number 2 looks like 0, 1, 0, just the way we want. So we've only got 1 left. But it's going to get a little bit trickier because we see we've got a 3 in front. Before we already had 1s as the leading number. Here we've got a 3 as the leading number, or the first non-zero number. So what I'm going to do is I'm going to do 1 over 3 times row 3 becomes my new row 3. So I'm going to have 1, 0, -1, -3, 0, 1, 1, 3, 0, 0, 1, 7/3. Throw that horizontal line. We close up the matrix. Perfect. Now we're almost done. So we've got row 3 with a leading 1, and we want to get rid of the numbers above it. So 1, and let's compare row 3 with row 1. Row 3 is a 1, row 1 is a -1, so we can really quickly do row 1 plus row 3 becomes my new row 1. For row number 2, they're both equal to 1, so we're going to have to do negative row 3 plus row 2 becomes my new row 2. So because these zeros are in front, the first two numbers stay the same, 1 and 0. Now we did row 1 plus row 3, so 1 plus -1 is 0. And then we're going to have 7/3 minus 3. So we're going to have 7/3 minus 3. For row number 2, the first two numbers stay the same because these zeros in row 3 don't do anything. And then we're going to have row 2 plus negative row 3. So 1 minus 1 is 0. We're going to have 3 minus 7/3. Whoops, that 3 looks a little wonky there. I'll fix it real quick. And then finally, row 3 was already the way we wanted it. 0, 0, 1, 7/3. So if we look at this last matrix, it'll tell us really quickly. Okay, remember this is column A, column B, column D, and then the answers. So by reading the column straight across, I can see that A, 1A plus 0B plus 0D, or in other words, just A, is equal to 7/3 minus 3. B is equal to, because remember, A is 0, D is 0, so B is 3 minus 7/3. And then finally, D is equal to 7/3. So just like that, we could simplify the fraction subtractions a little bit if we wanted to. You can always check out the fractions video if you feel a little unsure about that. But basically, at this point, we have solved for the three variables. So instead of doing a bunch of substitution, what we did was we just multiplied numbers and then added them together. So we can get rid of the substitutions if you don't like to do substitutions, so that whenever we solve a system of linear equations, we can rewrite the system of equations into a matrix. Once we have a matrix that represents the system of linear equations, we want it to look like the matrix on the right-hand side with 1, 0, 0, 0, 1, 0, basically just a 1 with zeros after it. So we do that by taking a number 1, making zeros below. Once you get to row number 2, you make zeros above and below. And we're doing this whole making of zeros by multiplying rows by specific numbers and then adding them to other rows. So remember, if you don't like doing the substitution and you'd rather do addition and addition, multiplication, we can also do that as well. So that's our little crash course on how to solve a system of linear equations using matrices. I hope that this little bonus video at the end of the algebra video has helped you guys out in case you're ever stuck and you don't want to do substitutions. So remember, just try your best and have yourselves a good rest of your day.